All right, all yours.
Cool. So, hi everybody, I'm Francesc Campoy, and today I'm going to be talking about, I decided to call the talk Doctor Power CLI Tools, but it's mostly about why CLIs are still useful and how we are trying to implement them at my company. I joined Sourced, that thing. It's not pronounced Source D, it's pronounced Source, and I will keep on saying this every time until people realize it. Or change the name of the company, that's the other option. But so I work at Source, and I joined in November to manage developer relations. One of the things that we do in developer relations is remove friction. And in order to use one of the tools that we had, it was around 20 minutes of setup for someone that knew what they were doing, right? So what I tried to do was to remove all of the friction as much as possible, and instead end up with a little binary that is kind of magic, and it does everything. And it kind of works. So today I'm going to explain how we built it, and basically, I'm not sure whether it's a good idea or not. It works quite well, but maybe it doesn't work for other people. So this is definitely a conversation. Feel free to ask any questions or remarks that you might have, because this is like beta product. We might still change things, so if you have ideas about like, wait, this is not secure, let me know now. Anyway, on top of this, I also have a YouTube channel, just for fun. Check it out, subscribe, and like, and whatever. I do it every 2 weeks, except that I have not done it for more than a month, because holidays and stuff. But yeah, it's all about Go. By the way, how many of you write Go regularly? Okay, so the agenda is going to be, first we're going to be talking about the history and how we went like back to the beginning. We used to have only CLIs, command line interface, and now we're back to basically every single project that is aimed to be cloud thing, Kubernetes, Docker, anything has a CLI tool, right? So why is this, and why does it make sense, or should we just avoid them? And then I'm going to be talking a little bit about our CLI, how we built it, the architecture, a little demo, and then show a little bit the source code itself. And then either I'm done and we're done, because I'm pretty tired today. Flew from San Francisco quite early. Or I have another topic which is a little bit more advanced, which is if you're putting everything inside of Docker and some of those things use Docker, what happens? You have Docker inside of Docker, and that's a really bad idea. So we had that issue too, and we can talk a little bit about that at the end. Again, this is a conversation, so feel free to interrupt me for questions or anything that you might want to ask, like where's the beer, for instance. I didn't find it, I found it second. But if you have any other questions other than that, feel free to interrupt me anytime. So, history time. At the beginning, we had MS-DOS. And we had just CLIs, right? Like there was no graphics, everything was a CLI, and people didn't say CLI because that was the only thing you had. Therefore, you didn't need to name it. The computer, right? This is what it does. This was pretty good, and eventually at some point in '83, we started getting these kind of graphical user interfaces, which all of a sudden brought a lot of really cool stuff. One of the things that it brought was the fact that now you were able to do multiple things at a time. There's Windows, right? That is pretty cool. Other than that, it is in between this and this. If you show someone that has no idea about computers, you show them this, they might be able to understand something. You show them this, there's no way they're going to know what to do next, right? So, GUIs brought a lot of value in the fact that new beginners to technology were able to embrace the technology much easier. You're able to add little tools like CLIs and stuff like that, so while you're working on something, you have something next to it, contextual help, all these things. All of those things, not a thing in here. Imagine CLIs here, that's the most annoying thing possible. CLIs is annoying by itself. On the CLI, that'd be amazing. But yeah, like this was pretty good. And then eventually we started moving a little bit into more modern games, like this one actually. So you start seeing games that start to use not only a little bit of graphics, but actually like they create worlds, and you can move around, and there's games, and this is far from the CLI, right? Like we've evolved a lot since the CLI. And then eventually you have things that people use all the time, like Word. And Word is a binary that you run on your computer. It's a desktop application. Cool. And then eventually it moves to the web. And now Word is not a desktop application. You don't need to install anything. You just go, sign in, and that's it. And this seems like a small thing, but it is actually huge. Because, again, as I was talking at the beginning, if we care about friction, which is one of the things that we care the most in developer relations, like new users should be successful, this is much easier than this. Just because here, you didn't need to install anything. Everything you need is a browser, right? Later on, more complex things start to evolve inside of the same browser. Things like Amazon Web Services, right? And you have APIs to control all of these things. And for instance, here, to launch an instance, it's pretty straightforward. You click Launch Instance, right? Now, the next step, once you have this, of course, is people want to automate this. And there's two options. Either you embrace it, or you fail. One of the ways of being a company and failing at this is, for instance, Twitter. I don't know if anyone works at Twitter. Twitter has amazing things like it allows you to see how many impressions a tweet has. On their website, there's no API for that, right? So the solution is pretty simple. You just do it on the website, you parse the HTML, you find the button you need to click, you click on that one, and then you parse again, and you get the number of things that you need to count. So the problem is, of course, that goes against terms of services. But these people will do it, right? Like, if the only way to launch an instance on Amazon was this, people will click, and now in this new version, whoops, fail, right? Like, this is very, very easy to break. If you have A/B testing on your website and things are changing over time, that will break. If you change a CSS rule, it might break. Anything could break this. This is super, super dangerous to write. And still, people do it because you don't have an API. Therefore, the next step is, of course, APIs. Now, you have things that you have, okay, so these well-documented API, you have REST APIs or gRPC APIs, whatever kind of APIs. The whole idea is that it's a well-documented thing that people can hit instead of the website, right? The next step is the website starts using the API, right? So now you have websites using APIs that everybody else is using too that hit some backend that you don't need to care about. APIs are everywhere. I don't know if you remember Yo. Yo had an API. What for? I have no idea. Apparently you can Yo people and receive Yos through webhooks. But this is important, right? Like, if Yo, which was relatively useless, had an API, that means something. APIs are important. Everybody has them. And if your company offers a service to other companies or even just developers, really, and you don't have an API, well, you have an API, which is what your website, and you're going to break your users every single time you update your CSS. So you need an API. So once you have an API, of course, APIs are not as easy to use as clicking, so you end up having client libraries. And these client libraries are super useful because what they allow you to do is write a little bit of code, maybe in Go or in Python. It's maybe like 2 lines of code, and it already does what you want. So it removes a lot of friction from using your API, which is great. And finally, you have CLIs again. Because now what you want to do is you actually want to remove more friction from the client library, which actually removes friction from the API, which removes friction from the website, which removes friction from all this, and you end up going back to CLIs. So nowadays, even though the CLIs are very different, actually they're kind of the same. We have a CLI that it's using some API somewhere, and everything you need to do is install this. And this is super useful. Now, I'm using this example, gclub. How many of you have used gclub before? Okay, so gclub is this tool, this binary that you download and then you run to manage things on Google Cloud. And it's written in Python. 2 or 3, half and half. And that's the fun part. It has extra things, like I'm actually gonna do the gclub components list. Every single one of those things is a different component. Every single one of those components is written in Python. And every single one of those components written in Python has multiple versions that can actually not work together sometimes. This is okay to use, to be honest. using it is okay, but I know how it's built. Oh God, this is this is hard. It is incredibly complicated and super brittle. Every single time there's a new version of some of these libraries, turns out that actually you're updating the library for BigQuery, which is not compatible with the one for Compute Engine anymore, and everything breaks, right? Painful. So, CLI tools, on one side, they're not very welcoming for beginners. You cannot really have contextual help. AV on the CLI, not a good idea. It requires installing it, and it can access remote things without you really noticing. Like when you're typing something, it doesn't mean that it just works on your machine. It might require connectivity, which is sometimes a problem. But on the other side, it is great for experts. If you're an expert creating a Compute Engine instance, normally you're going to do it with gcloud. You're not going to do it through the API just because it's much faster. It is much easier to script. You write a bash script that does the thing very well. And installation can be easy, actually. Installing, for instance, gcloud is just downloading a binary. So it's not that hard. You need to just tell people how to download it. You could have installers, so you can fix that. And also, you can access remote things. So you can make remote services seem like they were part of your computer, which is also quite cool. But, so trying to fix the problem we have. One is, it's not friendly for beginners. If you have never used that tool, you don't know how to use it. There's things you can do. Make it as standard as possible. Make it as boring as possible. Don't try to be fancy with your CLIs, right? Like Docker and Kubernetes and gcloud, they all look exactly the same. And that's great, right? Because once you know how to use one, you kind of know how to use the rest. -H needs to work everywhere. Like that. And that includes -H where it's not supposed to go. Like if you have subcommands and someone writes a -H in the middle of the thing, that should also work. -H is basically, I'm lost, please help, right? So help your user. Use subcommands. Like for instance, Kubernetes, you can do Kubernetes, actually Docker, you can do Docker run, but also Docker volume, whatever, Docker network, whatever. Like you basically are creating sub-menus inside of that command. That is very useful and very intuitive. And if you're using Go, I just recommend using Cobra. It just works really well, and it forces you to write something that looks like this, which in my opinion is great, because you don't need to think about how to organize your CLI. You just do it the Cobra way, anyways. So that's for the not being beginner friendly. What about requiring installation? So if you think about the client-server model, this requires installation, right? You need to install something on the client. And that client used to be a thin client, something like a little binary that you run, it opens a little window, and something happens. Then that kind of disappeared, went away, and now what we use is the browser, right? That you have the browser, and that's a really thin client. You don't need to install anything else. My idea is that the thin client that we have nowadays is Docker. Most developers have Docker installed on their machine. So my idea is to use Docker on the machines as that thin client that organizes the access to the server. So the client needs to be as thin as possible. And I use Go for everything. And Go has some cool stuff. Like for instance, you're able to create static binaries. You're able to create a binary, send it to someone that doesn't know what Go is, and they will be able to run it. Right? That's really good. If you think about many other languages, that's actually not that easy. If you think about Python, well, you need a Python interpreter, which is not really a problem, right? But okay, which one? Right? If you want to, I have a video of me during 30 minutes battling how to install TensorFlow, because I had TensorFlow 3, like Python 3 for Python 2.7, like it is not fun. You want to avoid those things. So with Go, you can do it very well. And on top of that, it's cross-platform. How many of you have ever used cross-compilation in Go? Okay, so just to show you a little bit how it works, like, so if you have main.go, that's going to be package main import from Seattle. So if you do go run manual go, that runs it. If you do go build, that generates binary here. There is 1.9 megs that is the binary, Linux binary. If I want to cross-compile it to Linux, to Windows, you can do go OS equals Windows, go build, and that's it. And now you have test.exe, which is the same size, and it is indeed something that you can run on Windows, right? So if you run everything in Go, your thin client, distributing to other systems is really not a problem. You can just do cross compilation and have it on GitHub as downloads, and that's it. Works pretty well. What about the nearby server? That server needs to be accessible as much as possible. Now, there's a problem with that. At Source, what we do is we analyze source code, and we apply machine learning on top of source code to predict things, detect bugs, and things like this. Now, if you tell this to a company that is using GitHub, they'll be like, yeah, cool. If you tell this to a company that actually cares about their source code and really a lot, like Google, and you tell them, you're going to be sending your source code over the network, don't worry, we use HTTPS. That's not going to fly. You cannot do that, right? So what I want to do is, I want those servers to also be running locally. And that's where Docker comes back, right? Like, now what I'm doing is moving that server inside of the computer with Docker. And how do you install it? Docker pull. That's it. You don't need to do anything else. So, this is the architecture that I came up with. So source is the binary that we wrote. And it uses gRPC to connect to the source server. And that source server, what it does is just, that's all of the installation of extra things that it may need, the configuration of volumes, all of these slightly more complex things that are basically orchestration of the different services we have. And it does that by using actually not the REST API for Docker, but instead it uses the Go client library for the REST API for Docker. So now what I'm doing is, when I do source init, for instance, source init is going to create a new container, which is the server, and that server is going to create all of the containers that it requires. So, quick demo. And in the style of magicians, I have nothing here. Wait, yeah. So, Docker PS, yeah, that was close. So Docker PS, there's nothing there, and Docker system prune. There's nothing, absolutely anything on my machine for Docker. So now I can do, actually let me go, source init. And now this is actually downloading that CLI daemon. That is the server. That is the only thing that is actually accessible to the client. And of course now I depend on the Wi-Fi. Okay, that's not bad. Cool. So it also uses a CLI network. It uses a Docker network. And this is because what I want to do is I want to have all of the services that I'm orchestrating, I want them to be able to communicate with each other. But at the same time, I don't want them to have port conflicts with all the things that are being run. When you're using a network, what you're doing is actually you can hide all of those ports and say those ports are only available to the things inside of the network. So you're not really using any of the host ports. I only use one. So if we do Docker PS, see now we have a daemon which is running, exposing just one port, 4242. And that's everything it does. Cool. So now let's say that, for instance, I want to do source help. So you can do source, bars, language, main, what's it? Oh no, I removed it. Package, main, that's Go. So if I do source, parse, lang, this what it does is it identifies the language of a given file. So you can do source, parse, lang, main. It tells you this is Go. Cool. Now the next thing I want to do is, actually I don't want to only know what language this is. I want to parse it and obtain the AST. It's not an AST, an abstract syntax tree, but we call it a universal abstract syntax tree. The universal part of it is as universal as JSON or XML, which means that we just agreed on a format. That's why it's universal, right? It's not because like all of the possible languages are represented in the exact same way, but all of the trees look kind of the same. And then we can extract things with CSS and XPath and things like this. So I can do UAC. And now this is going to be slower. So now what this is using is a different project. It's called Babblefish. So the first thing it's going to need to do is start running that Babblefish, which is still not running, because probably it's downloading it. So let's look at the logs. Alright, so it's downloading that Babblefish. The cool thing is that that is done by a Docker container. The way I make it so Docker is so that container is able to start new containers next to it is actually pretty straightforward, but I had no idea this existed, which is you can actually map the socket, the Docker socket, onto a container. So now what is going to happen is that the binary that is managing and creating containers, when it creates a container, it's actually talking to the same Docker host it created that container. Therefore not creating children, but siblings. Right? And that is because you're able to map one thing into the other. So you basically can do all the things you can do from outside of the container, but now inside, which is much easier. One of our engineers had the great idea that it'd be really good to install all of the drivers for all of the languages every single time. There's an issue about this, but because it doesn't make any sense, we just need the code driver. But now what you can see is that, so the container started, Babblefish is running, and now the orchestrator is asking Babblefish to install all of the drivers. Right, so all of these steps that before you had to do manually, now it's actually one extra container that is orchestrating all of these things automatically. I'm gonna say the network is not the fastest I've ever seen. I'm gonna blame the network. Because really this is what it's doing is just, because the interesting thing is that every single driver that it's installing is also a Docker container. So this is the part where we're running Docker containers inside of Docker containers created by Docker containers running in Docker. Yes, it's fun.
You mentioned something about a container to do orchestration. What container is that?
So since this is taking very long, let me show you some code here for the engine. So we have two commands, and there's this command. It's the source server. So the source server, this is the command that is actually managing all of the things from inside Docker. We run this binary inside of Docker to orchestrate all the things. And when we created, actually that's going to be this one. When we created us and then end.
So that container has Go, join Go inside. That's what you orchestrate.
Sorry?
So my understanding, looks like you're using Go to the Go program to orchestrate.
Yes. So there's a Go program running instead of Docker. So Docker PS. So now we have two different containers running. We have this source CLI daemon, which is the server that every single time you do source whatever, what you're doing is just talking to that. Why we do it that way is because there's a lot of dependencies that only run on Linux. Right? So source anything would probably not run on Mac. But now what I'm doing is when you run source anything, that's actually a gRPC command that is sent to the server that is running on Linux, and either it runs it directly if it's able to, or it starts a new component that will manage that. And that's why I was looking at this, which is taking forever. But it might actually have worked already. Nah, because it's still installing. That's so sad. Yeah, it will eventually work, but yeah, it takes forever to download all the drivers. But yeah, so the interesting thing is it's Docker network inspect. No, Docker inspect network. No, Docker network. Yeah. ls inspect source CLI network. And this is the network that has all of the containers running. So now, this one here, we are actually exposing the port for this container, but with a meet. We're doing it because we also have some of the things that I'll show you in a minute that might help. But it's not needed, right? Like we're able to start all of these services automatically without having to take care of port conflicts or anything like that. Yay, it worked. Okay. So yeah, this is the result. And now if I run it again, you know that parse just runs directly because not all of the parts are installed, right? This is something that now, yeah, it takes like, you need to wait for 3 minutes to have everything installed. Before this was 20 minutes of installing Bubblefish, installing drivers, installing the UI, all of these things in order to have them work, right? Similarly, we have another cool thing, which is, I'm gonna go to samples, engine, Jupyter. Right, so we have source kill, that kills all of the things. And now you can do sourced SQL, and do show tables. This is now downloading a SQL server. And this is a SQL server that allows us to find things inside of Git projects. The cool thing about this part is that what is happening is when you do source SQL, you need to install the daemon again because I just killed it. And now the daemon, when it initializes, it's actually initializing while mounting the current directory as a volume. And then Docker containers can pass that volume around. So you can also do that. You can pass networks, you can pass volumes, all of these things you can pass them around, which means that you don't need to install anything else and everything just works. Unfortunately, not fast enough because of the drivers, which I hate, but whatever. You can do even things like this. Source web Bubblefish. Source web Git base, for instance. And now what this is doing, source web SQL. Okay. No, because installing still the drivers. Source kill was a bad idea. So the interesting thing about this, anyway, is that this will actually even open the browser, right? So now what this is doing is it's going to install the daemon, it's going to install the SQL server, and then it's going to start a dashboard that you can use directly on Chrome to access those services directly. So you really end up having a similar behavior to what you would have if you had like a web server somewhere remotely, but everything happens locally. And once all the drivers are installed, it's actually fast. Once they're installed. Let me go back to. So yeah, what I wanted to show, actually I showed already pretty much everything I wanted to show in the code. I guess that the most interesting part is, so daemon dot kill, daemon, this package here, which is source daemon, source daemon. So this is the one that is going to start. It's going to map that socket. That is the name of the socket that allows this container to start new containers on the same host, right? And then when we created, let me see. This, when we're creating the daemon, we're creating it with the binary, all of the options that we want, but the most important part is this one here, this Docker socket. That is the, when you use in the CLI, the Go client, this is the part that is going to allow Docker to use Docker. So this binary to use Docker from inside of Docker. And all of these is open source, so if you are curious about how it's done, is github.com/source/engine. And how are we doing time? When are we supposed to like 4 minutes ago?
No, well, yeah, we're on time.
Okay, so I'm just gonna
You
show
can wrap up
you
whenever.
something really cool, because this is the part, like Paddlefish, this is the project that uses Docker. Every single parser is written in the language that it's parsing, which makes things much easier. Writing a parser for Go in Go is easy. Writing a Java parser in Java is easy. Writing a Java parser in Go, not easy, right? So what we're trying to do is simplify the process as much as possible so we can add drivers as quick as possible. Nowadays we're adding like at least 2 drivers per week. So that's pretty cool. Now the problem of course is that this is PHP, this is Java, that's Go, and they have all the different dependencies, so how do you run them all together? So that's easy, hard, and parsing C++ in Go, by the way, if you want to like hate yourself, it's very, very interesting. I tried, it is not easy. So yeah, like our solution is parsing every language in its own language, it's much easier. Parsing C++ in C++ is also incredibly hard, by the way. Don't think it makes it better. So we use Docker because of all of these reasons, and because Docker run is much better than apt-get plus pig plus brew plus curl/bash stuff, right? This is much easier. Docker run just works. People are aware. They can add their own security on top of it. So it's a well-known-ish problem. It's much easier to do this, I consider. So the problem is, of course, we have this container running inside, and so Docker run foo starts this container, right? So this is the computer, and when I want to run a container, I'm gonna run inside of Docker. So you have Docker inside of Docker, inside of Docker, inside of Docker. And Jérôme Petazzo, he used to work at Docker. He doesn't work at Docker anymore, if I'm not mistaken. He said, using Docker in Docker for your CI or testing environment, think twice. However, contrary to popular belief, Docker in Docker is not 100% made of sparkles, ponies, and unicorns. Which is true. This is really, really hard. And then later on, he was like, actually, you can just run this command, and now you're running Docker instead of Docker. Still, do not do it. So many things will go wrong, especially if you start mapping things, you're done. Like, this is really complicated. So instead, what we use is this thing. We can use var run docker.socket, the Docker socket, and this is what we use for the engine. And this works really well. So now what you do is Docker CLI, you map that, you create a container, and when Docker run foo runs, oh, it didn't do it. Okay, so when Docker run foo runs inside of this container, since it's mapping that socket, it's actually talking to that host, creating a sibling, not a child. And this is a super useful thing. Now the problem is that this is not enough for us. Because the problem is that also people want to run things without Docker, which is hard to understand, but there's many companies that are pretty large that say they cannot run Docker in production because it's not safe. I don't know why, but whatever. So for Paddlefish specifically, since we wanted it to be able to run it outside of Docker, we use libcontainer. How many of you know about libcontainer? Okay, not many. So if you want to create containers, but do not want to use Docker, libcontainer is the thing you want to use. So it's obviously open source. It was created by Docker and then given to the Open Containers Initiative. And the whole idea is that you have a Go library, and then you can just use that. Obviously, it only runs on Linux. Do not think that all of a sudden, just because of this, it's going to run on Windows. It's not how it works. But the cool thing is that this runs on Linux, which means that you can also run it inside of Docker, which means that now you can have containers inside of a container without having Docker inside of Docker. So many problems go away, not all of them. So that is how we manage all of our drivers. All of the drivers that we're installing, they are on Docker Hub. But when we install them and when we run them, we're actually not running Docker. We're just running libcontainer. That comes with fewer features. There's a lot of things that you can do with Docker that do not exist in lib container. Things like, for instance, mounting volumes is much harder. Networking is much harder. But what we're doing here is actually every driver simply needs to read from standard input and then print into standard output. That's our communication mechanism, which means that lib container works totally fine for us. So, and yeah, that's it. The rest is not really that important. But yeah, so the important thing of all of this thing is Docker, just don't. Like, sincerely, don't try. Like, try it for fun, and you're gonna see it is very hard and breaks very easily. So do not do that. Docker socket, mapping the Docker socket allows you to not run Docker inside of Docker, but to manage Docker from inside of Docker. The difference being is the new containers that you create are not children of a container, but citizens. And this solves a lot of problems, and this is what we're doing for the engine. And that solves like 99% of our problems. And finally, what you need is really like no Docker at all. You can still run containers with lib container. And that's way fewer features, and it only requires Linux, which is great. It doesn't require to have even Docker installed, just with Linux is enough. And for some very simple things, it's the best solution. In our case, for bubble fish and managing drivers and consoles, it's the best solution. We're hiring. So I'm here because I'm actually looking for an office. So if anyone knows a good office that they want to work from, that would help me. But yeah, so we're hiring. We're in San Francisco and in Madrid and all around the world. We're remote, but we're opening our next office. Our third office is going to be here in San Francisco. So if you're interested in like doing weird things with Docker and machine learning and languages, analysis, and parsing, all that stuff, check it out, source.tech. And if you have any more questions, we have some time now, but also feel free to send me emails or tweet or whatever. I'm more than happy to answer questions later. Thank you. Are there any? Yeah.
So I'm just not that familiar with accessing Docker API. Is there a good source of documentation on what's available to access within the API from the socket?
Oh, basically everything. So when you're mapping, so the whole thing is that when you are running Docker here, this binary is using that socket to connect to this Docker data, right? So everything that Docker, the binary, the CLI can do, you can also do it through the API, which means that also you can do it from inside another container. So
from a code example.
Yeah, so there's actually under engine, I think I created Docker. There's an example. There's basically removing all of the complexities, so you can do something like info. It gives me information about a container. This is basically like Docker inspect a container. You have this is the Docker client. And then you can do all the things that you would do from the API directly with Go here. This created this auto-generated library that is based on the API, on the REST API. So I'm sure that there's also the similar thing for Python or any other language that you might want. So basically, the Docker daemon is a REST server that you can hit, not opening a TCP connection, or actually it is a TCP connection, but instead of opening a network connection, it's just a local socket.
You access Docker Compose API in the same way? Or is that for a separate?
Can you access the Docker API?
Docker Compose.
Docker Compose, I'm not sure. That is interesting. I decided not to use Docker Compose because Docker Compose, for the things that I wanted to do, like there's some cool stuff like when you do the source, the parse USD. The first step is it detects what language it is, and then it downloads a driver for the language, and then it runs it. Right? Doing that with Docker Compose is actually quite hard. So I decided to avoid, to make the orchestration manually rather than using Docker Compose. Docker Compose would be a really good option also if the orchestration you need to do is much simpler. You could just do Docker Compose up and then, or even your binary could run Docker Compose up if you want to have a binary. That was worth it, yeah. Yeah.
What was the reason that you guys moved the syntax tree, generate, what do you want to do with that?
So the question is, why did we build this thing that's word of knowledge? So the whole idea is that what we're doing is we're learning from source code, and in order to learn from source, actually let me show you something really quick. I think that's good, because I have an example of what we're doing. This one. This is my gopher on top, and there was a moment. Cool. Okay. All right. So when you think about source code, you can think about source code as a sequence of characters and learn from that, and that works. But the problem is that you're actually now providing a lot of the information you have from the program, because we know that package is a thing. It's just not like a sequence of characters, it's a specific thing, right? So you're not giving that's a problem. You can also use the tokens. And now you're giving a little bit more information, but you're not giving enough. The next step is you actually parse it and you give the AST. Now the problem is that if you want to learn from different languages, and every single language has a different way of representing that format, that AST, then actually you cannot really learn that easily. So that's why we have to find a common representation for all of the ASTs. And this is actually very useful, not only for learning, but so there's this thing called code zoner that does a bunch of different checks on Java, and I think C++ too. What we did was apply those checks on top of ASTs. So now what you can say is as long as it's a programming language that has for loops and if statements, all of these checks work.
So you're doing it to learn from the syntax tree, not necessarily do anything with the syntax tree itself.
We do so. The next
Or
slide
are
is
there intelligent suggestions based on machine learning from the syntax tree.
yeah. So the main reason is because we need to do machine learning from source code, so we need a better representation, and that's why we created it. Now that it exists, we actually notice that there's many tools that could be language agnostic. That, for instance, creating a control flow graph. It's nothing related to the language. It's just how you jump around instructions, right? So whether it's Java or Go or whatever, you can still just write the algorithm you want to make it work. And this actually, the UAST, the concept of UAST, is something we're working with. The only other company that has ever tried something similar, which happens to be GitHub. So we are actually trying to agree on, let's agree on a format, so we can then share it and work together on
That's
it.
really interesting work. I work for a company that does some compilers, so we
Yeah.
work a lot with ASTs. That's really interesting stuff.
Yeah, it is. So the most important thing is that it's actually super simple, right? The most important thing about the ASTs is that you get, it's a tree, then it's a tree that is formatted pretty much the same way for no matter the language. But also, the fact that we have these roles here, those are language agnostic. So what is a statement, what is a function, what is a boolean, all of these things are language agnostic. So then I can go here and go like, comment? No, not comment. Let me see. Oh, because we changed also the grammar for this. So internal tag comment, I think it's something like this. Nope. Comment? Nope. Like this. It's XPath, which is not the easiest thing to write. But basically the whole idea is that once you have represented the same way, one single library can extract nodes that you care about. So we have things like extract all the things that are an identifier that is inside of a function, which is also a declaration. So with that, you can extract the function name no matter what function it is. Right, so that's like that extra level of abstraction that we're doing.
So
Yeah.
actually another question about small nodes at Oracle does most probably something similar. They have Graal VM recently introduced, and they use truffle representation. So Graal VM is at runtime, like generic runtime for different languages, and truffle is a representation of different languages to like some same type. Yeah, so it might be something similar.
But is it like a common bytecode?
Yeah, kind of.
Okay,
so
so
they're
that-
using GDM to
Yeah.
run the code and to run like checks and so on. And so
Yeah,
forth.
so the main difference is, so there's also Huawei, for instance, they do kind of the same thing. They compile everything to the same like runtime that they use in the chips. No matter if it's JavaScript or Go, it ends up being the same thing, which is kind of crazy. But what we're doing is different because we want to keep the code, right? We want to be able to analyze the code, not the result of compiling it. So there's no optimizations, we keep indentation, we keep, there's a lot of things that are completely useless from a point of view of I'm going to run this program that we really care about because that's actually what we work with. So yeah, there's similar efforts on having like universal compilers, and universal parsers, but not a universal representation, which is weird.
So is there an online document for people who wanted to look at the spec of the abstract tree structure that you're
Yeah, BBL-F.sh, which I don't like necessarily, but it's Bubblefish. Or also if you go to source.tech, our website, and then you go to open source, we have a bunch of different projects here. So Bubblefish is one of them. Everything we do is open source, so if you want to check anything, we really need somewhere there. Cool. Any other questions?
All right. Well, thanks for flying down from San Fran, Francis.
Thank you.
Appreciate it.